This question here. It's a solid cone, which means it's not empty. It's fully, if you were to slice it in half, it would be completely filled. Find the height of the cone. Now, the height of the cone is, to get the height of the cone, we got to do Protagoras' theorem. And to do Protagoras' theorem, it's going to be the longest side, which is 13, equals the other two sides squared and added together. So 13 squared equals h squared plus 5 squared. 13 squared is 169, h squared is still the same, and 5 squared is 25. Bring 25 over the other side. It becomes minus 25. So we're going to get h squared equals 144. Square root 144. H equals 12 centimeters. We now know that the height of the cone is 12 centimeters. Okay. Now that we know this, we're asked to find the curved surface area. Okay. Curved surface area is pi RL. So we call it CSA, curved surface area, equals pi multiplied by R multiplied by L. Does it want me to use pi in my calculator? Probably does. So it's pi multiplied by 5 multiplied by 13. And what do we get for that in our calculator? And change 65 pi into decimals. 204.2. 204.2 centimeters squared or cubed? Anybody? It's an area, centimeters squared or cubed? How many, and you can also count how many lengths you multiplied by each other. You multiply 2 lengths by each other, so it's going to be centimeters squared. Next one, find the total surface area. What do we have to add on, guys? We have to add on the circle on the bottom. What's the area of a circle? Pi r squared, which is pi times 5 squared. Put it into the calculator, change it to decimals for me. Anybody? Uh, 78.54. I'm going to change that 39 into a 40. Okay, 78.54. Now, how do we get the total surface area? Got to add them together, aren't we? So it's going to be 204.2 plus 78.54. And what do we get? Okay, 282.74. Okay, now that's that one done, that one done, and that one done. Now we have the volume of a cone. Okay. Now the volume of a cone is the formula here: a third pi r squared h. So a third pi r squared h, and that's going to be a third pi r squared is 5 squared. H is what do we get h as? 12, wasn't it? So it's 12. Put all this into the calculator, and what do we get? What do you get? 100 pi, is it? Or 125, I'll find out now. 100 pi, which is 314.16 centimeters cubed or centimeters squared? Cubed. Remember, 2 lengths in radius squared. The third length is the height. That means it's centimeters cubed. To give your answer to one decimal place where necessary. Oh, so this is going to be 282.7 and 314.2. Just make sure you read the question and do exactly as the question asked you, okay? Now, when an object is immersed in water, the volume of this cone results in a volume change of the water that's equal to this small cylinder of water here. The water is cylinder shaped because it's inside a cylinder. So step one is to find out the volume of the cone. So to find the volume of this cone, we need to just draw the cone quickly, and we'll do it like this, and down it goes. Not bad, right? Now, what I'm going to do next is going to write down the dimensions of the cone. The dimensions of the cone is 6. It's going to be, oh, it tells me it's A high, doesn't it? No, it doesn't tell me it's A high. So it tells me nothing about the... Alright, it does tell me, however, the height of the cone is 12, doesn't it? Now, to find the volume of a cone, what do we do for the volume of a cone? 1/3 pi r squared h. Do we need to find L in this question? Do we need to find L? No. The reason why we don't need to find L is because it's basically not used in the formula we're going to use. So it's going to be, we're going to leave it in terms of pi. 1/3 pi 6 squared multiplied by 12. Okay. 6 squared is 36. And 12 is there, so we're going to get 144 pi. Okay, 144 pi. Now, if the radius of the cylinder is 8 centimeters, find the value of h. So the radius of the cylinder. So the volume of the cone equals the volume of the cylinder of water. Not the full cylinder, right? Just this part here. Yeah? What's the volume of this cylinder of water? Can anybody tell me? It's pi r squared, isn't it? H. It's going to be pi. What's the radius?
8.
8 squared. H, yeah?
Yeah.
And that's going to be 64 pi h. Therefore, volume of the cylinder of water equals volume of cone. 64 pi h must equal 144 pi. What happens to the pi's? We cancel them off and divide. H is 144 divided by 64, which is
9 1/4.
What is it?
2 1/4.
2 1/4. That sounds about right. 9/4, which is 2.25 or 2 1/4. Okay. Now, wax in the shape of a cylinder of radius length 4 centimeters and height 36. So it's 4 centimeters wide, not the scale but the looks of it, and it's 36 centimeters high. The resultant wax is formed in the cone-shaped candles as shown. Each cone-shaped candle has a height of 6 and a radius of length 2. Calculate the number of candles that can be made, assuming no wax is lost. Let's find out all the volume of the cylinder is changed into cones. No volume is lost. So volume of a cylinder is pi r squared h. Let's keep it in terms of pi starting off because it might be more accurate. Pi multiplied by r squared, anybody? 4 squared by 36. Let me know what that is in the calculator. What'd you say?
576.
576 pi is what we're going for? Yes, it is 576. 576 pi is the volume of the cylinder. Now, what's the volume of a cone? Is 1/3 pi r squared h. So what do we think now? Volume of cone, anybody? A third pi, what's the radius? 2 squared, what's the height? 6. Let's put that into the calculator and figure out what it is. 8 pi. Well done. Now, how many 8 pi's fit into 576 pi? This will tell us how many candles are the size of the cylinder. So number of candles equals volume of cylinder divided by volume of cone, volume of candle. And we said that's 576 divided by 8, and what did you say? 72. 72 candles. Next question. The candles are placed face down in a row of 6 in the smallest possible rectangular box. Calculate the volume internal capacity of the box. So what I want you to imagine is this. Okay, let's basically this, isn't it? No. Oh yeah, this makes it easier now. Okay, so that's how many is that now? That's 4. Okay, there's 4 of them, right? And there we go. 4, and then finally last 2, 6. Okay, so what we're doing here is there's our 6. Now what we're going to do is we're going to have a basically that's our 6 cones there. Okay. Now what we're going to have is a rectangular box that goes around all of them. So, and it barely fits, know what I mean? Barely fits just above the top, right? And enough for the base. So that's the front view of it. Now, can anybody tell me what is the width and height of this box? The height is going to be? Anybody? What's the height of the candle? 6. And what is the width? What's the radius of each candle?
2.
So what's the diameter of each candle?
4.
4, 4, 4, 4, 4, 4, 24. Okay? Now, if we take a frontal view or a back view, how many candles do we have again? We have 72, don't we? If we fit 6 into a row, how many rows do we have to go back? 12. So, if I was to give you an aerial view of this then, it'd be something like this, and there'll just be 12 circles. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it fits. Okay, and how long would it be? What's the width of each candle, or what's the full length of each candle? We have it here. 4, isn't it? How many 4s? 12 4s, right? And what's 12 4s? 48. Therefore, the volume of the box is length by width by height, which is going to be 6 by 48 by 24. And what do we get?
6,912.
6,912 centimeters cubed. Okay.